Consider a function f of n variables x1, x2, and so on up to xn. First, we will find the critical points, which are the points where all first-order partial derivatives vanish. So, we will set each partial derivative equal to 0, and we will solve the system of equations. Next, we have to consider the Hessian matrix associated with F, which is a symmetric matrix that contains all combinations of second-order partial derivatives of F with respect to all variables. We will call this matrix H and arrange the derivatives in the way that you see on the screen. Considering the Hessian matrix, we have to compute all its leading principal minors. The kth leading principal minor of the Hessian matrix is the determinant of the upper left k by k submatrix of the Hessian matrix. So, the first one is directly the upper left entry. The second one is the determinant of the 2 by 2 upper left submatrix, and so on up to the last leading principal minor, which is the determinant of the full matrix. Once we have all critical points, we have to evaluate the Hessian matrix at each of those points, compute all its leading principal minors, and verify in which case we are according to the following conditions. Case 1. All leading principal minors are positive. Then the critical point is a local minimum. Case 2. The first leading principal minor is negative, and the subsequent leading principal minors alternate in sign. Then the critical point is a local maximum. Case 3. All leading principal minors are non-zero, but the conditions of case 1 and case 2 are not met. Then the critical point is a saddle point. We are going to see an example of how to identify the right case and classify all critical points. Consider the function f of x and y equal to x cubed minus 3x plus y cubed plus 3y squared. First, find the critical points. To do this, compute the partial derivative of f with respect to x and the partial derivative of f with respect to y. Set them equal to 0 and solve the system. You will find that there are exactly 4 solutions, which are the points that you see listed here. Now obtain the Hessian matrix. Since f is a function of 2 variables, the matrix will be of size 2 by 2, and its entries are the different combinations of second-order partial derivatives with respect to x and y. For our case, the general Hessian matrix in terms of x and y is the one you see on the right. Now we are going to analyze each point independently and classify it. Consider the point -1, -2. Consider the Hessian matrix evaluated at this point, and now we are going to compute all its leading principal minors. The first leading principal minor is the determinant of the upper left 1 by 1 submatrix, that is just taking the upper leftmost entry, which is -6 in this case. And keep in mind that it is negative. The second leading principal minor is the determinant of the upper left 2 by 2 submatrix. Since we only have 2 variables, this is the last minor that we have to consider, and it is equal to the determinant of the full matrix. In this case, the result is 36, which is positive. Now recall the rules about the signs of the leading principal minors that we saw earlier. For the Hessian matrix associated with this critical point, we found that the first leading principal minor is negative and the second leading principal minor is positive. Since the first one is negative and there is an alternation of signs, we conclude that the point -1, -2 is a local maximum. In general, if the function had more variables, we would be looking for a pattern of the form negative, positive, negative, positive, negative, positive, and so on. Now consider the point -1, 0. The Hessian matrix evaluated here looks like this. The first leading principal minor is just the upper leftmost entry, which is -6, and it has negative sign. The second leading principal minor happens to be the determinant of the full 2x2 matrix, which is now -36 with negative sign. So first, notice that all leading principal minors are non-zero. And now, according to the cases that were described earlier, notice that we are not in case 1, because not all leading principal minors are positive. And we are not in case 2, because there is not an alternation of signs starting with a -1. Thus, we conclude that the point -1, 0 is a saddle point. Now consider the point 1, -2. The Hessian matrix evaluated here looks like this. The first leading principal minor is 6, which is positive, and the second leading principal minor is equal to -36, which is negative. Don't be confused by the fact that the signs alternate, because the condition for having a local maximum requires that the first leading principal minor be negative. And we have the opposite. This is actually another saddle point. Finally, consider the point 1, 0. And the Hessian matrix evaluated at 1, 0. The first leading principal minor is positive, and the second leading principal minor is also positive. Since all leading principal minors are positive, this is clearly a local minimum. In conclusion, our function f has 4 critical points, and our criterion for the signs of the leading principal minors of the Hessian matrix at each critical point allowed us to classify them. There is a local minimum, a local maximum, and 2 saddle points.